we need to actually maybe get out a notebook or a piece of paper. I have free paper on Student Work Center. And Monday I'm actually getting the school money so I can buy a lot of supplies like pencils and things like that so that students can have those again if you don't have one. But there's always, the school system, well, the state of Alabama always gives teachers money to buy school supplies.
It's a random time in the year for them to just.
Well, no, so you get the money, the fiscal year, meaning the financial year, always starts over in October. I used to think the same until I found out why. The actual calendar year starts over in January, but what's right before January?
Christmas.
Christmas. Does anyone want to be working to wrap up the financial year in Christmas time? No. So they wrap up the financial, so we split the year into quarters, right? And so January to March is a quarter, April to June is a quarter, July to September is a quarter, and then October is the new fiscal year.
If you have extra money, do they let you carry it over to the next one, or do they just take it? They just take it?
They just take it from us, so that's why I'm going to be using all of it
Yeah,
to buy supplies. Alright, so let's look here again. We need to be careful. I see a couple of equations that are close or absolutely correct. We did recognize it's exponential. Does anybody see an equation we should be wary of because we're misidentifying something?
X minus 2 is over here.
The one with the 2 3.
Okay, so one with the square, we're going to talk about that later. There's another one that I want us to be careful about.
The 2 3s. The one that's.
This one here.
Yeah. It's
So that looks to me like someone just typed it in wrong. Notice if you don't put the parentheses like this, it's going to multiply by 2 and it's going to divide everything by
When
3.
I put an exponent, it put the parentheses for me.
No, because it tricks you, because
So
it'll look right on your screen, but then when you turn it in, it does that.
Well, you need to be careful, and if you actually hit enter, you'll see how it types out. You might have to go back in and check it again. But you have to be careful, and Gracie is correct that if you put in the exponent, right? Well, I'll say this, you need to put parentheses around the 2/3, right? That 2/3 is together, and when you put the exponent, it definitely makes it go together. But I was thinking about this one down here. A lot of those things look very correct, but what's the issue with that equation?
The exponent. There's no
It's not a loop, we're not adding.
We're not adding. That's the equation of a linear function, right? Be careful. We all talked about the fact that we're repeatedly what? Multiplying. We got to know our equations. If it is a line, what is the equation we can use? Y equals mx plus b. Or, I know Lexi likes the a plus bx. I'm in the same boat. You use whichever one you want. But if it is exponential, remember we are repeatedly what? Multiplying. So y is equal to a, my y-intercept, times b raised to the x. Remember, the exponential equation is why I really like for a linear a plus bx. It's the same idea. My y-intercept and then my rate of change, whether I'm repeatedly adding or repeatedly multiplying. But again, that's part of the issue here. That person was multiplying by x, not raised to the x. Not sure about here. Hopefully, if you did this, you see how we would fix that. Notice we need, first off, we definitely need the y-intercept, which we'll talk about in a second. But you also need to make sure to show repeated multiplication is your common ratio raised to a power. So what was it that you had an issue with up here, DJ?
It's supposed to be, the exponent's supposed to be x.
Yeah, I think I put 2.
Yeah. Remember, times 2, or raised to the 2 is only going to multiply by 2/3 how many times? Twice. Does that account for every possible input?
No.
No. We need that exponent of an x, so be careful about that. From there, so let's look again at the table really quickly, because I know that this is a detail that may have skipped, or some of us may have missed. To have a y-intercept, or why do we know we don't have the y-intercept yet?
You don't have 0.
You don't have 0 for the x, right? We got to keep going until we get that 0 for the x. If you want a y-intercept, x has got to be 0. Jeremiah, it is hard to learn when you're not even looking at the board. Come on. I want you to be successful. You got to put in the work of literally just at least looking at the board. Okay. So what was the rate of change we identified here?
Times 2/3.
So I just keep going. And if you do 48 times 2/3, would it come out to be 32?
Yeah.
And then times 2/3 again. And again, remember, you can just use a calculator. Like, you don't have to know 32 times 2/3 off the top of your head, but it is 64/3. And that's where our y-intercept's coming from. A lot of this work getting to that y-intercept, but, alright. Any questions from there?
How did you?
So if you want me to show you how I get it without the calculator?
Yeah.
Okay, so with the calculator, obviously you can just type it in, but remember when you multiply by fractions, you multiply across the numerator and across the denominator, that 32 is understood to be divided by 1. So 32 times 2 is 64, 1 times 3 is 3. That's it. Make sense?
What is that thing called when you like multiply like the 2 and the 1 and the 32 and the 30? We used to do that with like.
Well, It's called cross multiplying, but don't do that here.
Okay.
What you're thinking about is if I have x divided by 2 is equal to 32 divided by 3, you could cross multiply there, but even then, don't. How would you solve this equation? No, they're equal. Y'all. This is an equation.
Times 2.
Thank you! Instead of taking the effort to cross multiply, I'm solving for that x. It's being divided by 2, so multiply by 2. Don't make it more complicated than that.
So why didn't it was possible?
Yeah, why do we do that?
100%. Putting this somewhat delicately, you learn that technique in late elementary school or early middle school. A lot of those teachers were taught to cross multiply and they don't understand why.
I don't even understand why.
It's common.
That,
No, that is not Common Core math. That is math that came well before Common Core, and that's part of the issue. I know Common Core has a bad rap, but Common Core is just state standards. But before Common Core, all people did was memorize mathematical rules without understanding why those rules worked, and so then they just taught students to memorize those rules without understanding why they worked. So, elementary and middle school teachers typically aren't as strong in math, and that's not to say you can't be, but typically if you're a stronger math teacher, you go into high school. And they don't understand why we cross multiply. They're starting to get away from that finally though.
If you worked at Inglewood, you really have to like kids.
You really have to like kids?
Mm-hmm.
Is that bad?
I
That rough
like
over there?
certain ages. There's just some, like the middle school area where it's like, everybody's just in each other's business for no reason, you know?
Yeah, y'all never do that in high
Like in
school.
sixth
That is
grade.
absolutely high school.
I don't do that in high school, 'cause I
Absolutely.
don't talk to nobody.
Everybody
get-
Say something
y'all
about me,
get
I'm principal,
messy.
I might speak to you.
Alright,
Yeah.
so what do you think the best strategy to solve 2x squared minus 6x equals 2 is?
I'd subtract 2 first to make it a 0.
So first off, and I will say this, you didn't have to subtract the 2 to tell me which strategy. No, and that's fine, but I will point out, we need to be careful. So someone is using the quadratic formula, not a form, but quadratic formula. But you have to be careful. The quadratic formula only works when you're equal to what?
0.
0. The way I know that we have not gotten equal to 0 yet is, remember how it's minus 4ac, and they used a 2 for the c, but that 2 is on the right hand side. What do we need to do?
0.
Subtract 2. So what is my c actually? Negative 2. We all good on that idea? So very close on using that quadratic formula, but that's something to be aware of. So yeah, definitely get the zeros, graph it, subtract 2 on both sides, then graph it. It's in standard form, so we could probably graph it and use vertex and factored form, or we could use quadratic formula. Okay, but here's the thing I'm trying to get you all to think about. Which one is the best? Right here, this is what we want to notice. The vertex, because the roots are irrational. So if the roots are irrational, do we want to do factored form?
No.
No. If the roots are irrational, I'm probably going to jump to vertex form, or if you're like, man, I like the quadratic formula, I'm good with that. Okay?
Did I say this right? I said vertex form because the
That's the next one.
vertex points were rational.
Yeah, you can say that. The points of the vertex are rational, right? Yeah, so the vertex form, the points of the vertex are rational, and kind of the implication is also that the x-intercepts are irrational, or maybe you just really like the vertex form. Cool. I will also make this note. Do you have to be equal to 0 to use vertex form? No. You only have to be equal to 0 to use factored form and to use the quadratic formula. there is that beauty in the vertex form that I don't have to get it equal to 0. So we'll look at that more often. I'll go ahead and tell you, we're probably not going to get to the understanding check today, so we'll do it Monday. That means we won't be able to test till Wednesday, but we will be testing on Wednesday. I've already made the understanding check. What I did is you have 3 equations that you have to solve, and with those 3 equations, you have to do one as the quadratic formula, you have to use one as factored form and one as vertex form. Did I tell you which ones you have to use? So you need to be strategic in which one you do where. I did design the equations so that they would be, one would be easier in factored form, one would be easier in vertex form, and then one would be like, yeah, I want to use quadratic, okay? So you need to know when each strategy is useful. So I'm giving you a heads up right here and right now, while we're not sleeping, right, Jaden? There we go. I'm giving you a heads up right here and right now that you need to know how to use each strategy and also be strategic in each of those strategies. I'm not hiding that from you. And so that's why I have this question in the bell ringer, right? So what would be the best strategy? Oh, well, those roots sucked. They were irrational. And so the vertex form wasn't bad, but then also can we use the quadratic formula? Yes. Okay. So that's something to be aware of. And then some of us were having fits with writing an equation for the function to the right. I do notice that some of us, or most of us, quickly jump to using which form? Factored form, okay? So do we want to leave it with an A? No, remember we do want to figure out what that A is. And I know we're having some trouble getting through this one, so I'm not going to count that one against you if you didn't finish it. But let's look at this one again. So I want you to notice, a lot of us went straight to factored form. And why does factored form make sense? The x-intercepts are really pretty, aren't they?
No.
The x-intercepts aren't? I mean, that's a -2. That's not even just rational. What other number would we consider that? Anyone remember what that number is called?
It's not a decimal. What's it called?
An integer, right? The integers, remember, are your positive and negative whole numbers. What were you saying? You saying imaginary? We haven't gotten too much into the imaginaries. And then 3, 0, that's an integer, but remember that's also a whole number or a natural number. So those are really pretty. Could I have done vertex form? Yeah. Sure.
I don't know, you budget.
Okay. I will point out, I don't think everyone got 0.5. They got something 0.5000, and then some other decimals. That probably comes down to rounding error. If you see something like that, just assume it's 0.5. Right? Whenever you go to write this, be careful. What is the first thing I'm asking you to do to make your life easier and make sure you don't make mistakes?
Write the general.
Write that general equation. Right? F of x equals, what is general for factored form?
A parentheses x minus R1.
Oh, thank you. You're right. We're doing factored. R1 times,
X minus R2.
right. Be careful about that. F of x is equal to, we don't know A yet, x minus a -2, so how am I going to rewrite that? Plus 2, right? Remember, that's the whole thing. Write it that way, and then it makes it easy to remember when to correctly switch it. But I do still need f of x. I think from what I saw, everyone in here was using the vertex as the other point to figure out what A is. Does that sound right? Yes? Personally, I wouldn't. Does anyone know why? You 100% can, I just wouldn't.
Wait, how did you say you did it?
Used this vertex as a point, because remember, what could that 0.5 be substituted in for? X, and 12.5 could be substituted in for y, right? So that's what a lot of people were, the people who were getting that equation, that's what they did. Does anyone know why I personally wouldn't do that? It's a very simple thing.
It takes a long time.
No, I'm okay with time. What kind of numbers are they? Decimals, not irrational, but they are rational. Do you want to deal with decimals?
No.
Personally, me neither. Here's a really nice point. -1, comma, 1, 2, 3, 4, 5, 6, 7, 8. Now I've got integers. Similarly, I could have done 2, 8. Wouldn't that have been easier? Okay. So that's just strategic things. Could you have used the vertex? 100%. But those are the points I would have used. So maybe 8 is equal to A times 2 plus 2 times 2 minus 3. And DJ, what did you find out that we should do here to make our life easy?
Multiply the two things in parentheses.
I wouldn't multiply first.
Add them.
Add them, right? Follow your order of operations. What's 2 plus 2? 4. What's 2 minus 3? So 8 is equal to negative 4a. Notice I don't have decimals now, so this makes my life way easier. What is a supposed to be? Negative 2. Okay. We good with that idea?
Where's the negative 4 come from? Oh, never mind.
You good?
Yes.
So a is negative 2. And so that's one way to approach it. And I will go ahead and tell you this kind of problem will definitely be on the understanding check. Just one of these, but I'm not telling you whether it's factored or vertex form, you have to make a decision. But I will point out again, could I have done vertex form here? Yeah. X minus 0.5 squared plus 12.5. Similar thing, if I go through the process, what's a going to come out to be? Negative 2, right? I'm not going through the work just to save time, but we already know because of doing it once that it comes out to be that. And so even though they're different forms, because they're describing the same function, we know they are what? Equivalent, right? One's just a factored form, one's a vertex form, but those are equivalent equations. You choose which one is best for you. You just have to be aware of which features you have. Thank you. So we'll go from there. But any questions about these bell ringers? I know there was a longer time spent on bell ringers, but I felt like they are problems that we need to approach and discuss and think about before an understanding check. No questions? Going once, going twice. All right, moving on. I know I shocked you because you expected me to say sold. You got him. All right. So our agenda was that we're going to do lesson 6. I want to believe in the understanding check. Just seeing where we are. We're going to start Monday with that understanding check. Be aware of that. Okay. We're going to try to do our best with wrapping up lesson 6 today, or at least getting through activity 6.1 and 6.2. Any questions? Okay. We started to talk about lesson 6 yesterday, just briefly. What kind of number, I think we said the number, what kind of number are we talking about when we get to lesson 6? Imaginary numbers, right? So there is a thing called an imaginary number. Does that mean they don't exist? They are in our imagination? No. Say again. Say it louder. Right, they're also called complex numbers, and so a big thing to be aware of is, oh yeah, I do need to talk about the graphic organizer, thank you. A big thing to be aware of is that we need to attend to the idea of what a complex number is, or an imaginary number. They're very real numbers that are just not called that. And so we need to understand properties of the set of complex numbers. We need to rewrite expressions involving imaginary numbers. Rewrite expressions involving negative roots using I, stuff like this. I'll go ahead and tell you, my third block Algebra 2 students have already gone through this lesson because my placement student that comes in later in the day, she had to teach that lesson for an observation, and so even they were like, yeah, this beginning is super easy. So let's knock it out, try to get through activity 6.1 and 6.2 today. It should not be bad, but let me know if you have questions. The graphic organizer. So I'm not going to collect this for a grade like I do with the other graphic, or I usually do with the graphic organizer just because we're late on time. And by what I mean by that is I'm not going to collect it as a grade until test day. So I'm going to collect this on the day of the test. If you want to work on this graphic organizer and give it to me Monday, I will give you feedback Monday night and give it back to you Tuesday to study for the test. And I won't grade it Monday night, I'll just give you the feedback. And then you turn it back in on Wednesday to get the grade. But the whole point of these graphic organizers, it's 2 sheets so far, but this is effectively your study guide. This is what you need to pay attention to, and that tells you what lessons to look at if you take the time to just identify what lesson did this thing come up under, right? and then you write descriptions and give examples, and that's a summary, right? So on this, it's 2-page summary, front and back, and then there's the other graphic organizer, front and back, that summarizes the entire unit. Take the time to fill them out well, look at the feedback on there. But as I said, if you want to get done before Monday, this part, it would not be a bad idea. So we briefly looked at this, we talked about a couple of details. What I do want you to do is I want you to take about, let's say 7 minutes, 2 minutes per graph, list all the key characteristics you know about each function. Be sure to include the number of zeros, the x-intercepts, the y-intercept, the axis of symmetry, and the vertex with the graph. It shouldn't take too long because you have the graph given, you have the equation given, and then I want you to compare the 3 functions, what they have in common, what is different. Any questions before I ask you to get to work? 3, 2, 1, go. So talk about the graphs, get those features.
But it touches the line at 5, would that be part of the equation?
Yeah, he said those are negative or positive.
Would it be 0, positive?
No, 5,
It's on the first one, it says that.
Is it like that for both of the?
Yes.
I don't know, I'm asking, it's more like, there's only one vertex. Because you know how we used to do 5, 0.
Does
and like 8,
the
comma
x or
0
y come
something,
first?
and that was- Yeah, well.
The x, so it'd be 5,
Oh,
comma.
because for the
0.
since we don't have 2 on the x-axis. So like.
That's your
this
x.
one we would have 2
Get
on
what we
the
were-
x, there's 2 different sides.
Well, this one just gave us the vertex, which means we already have
There you
a,
go.
But this it's the x-intercept is 5, comma 0. Because the x is 5. Right? X.
I thought A was the vertex.
Yeah, the vertex also is 5, comma 0.
Oh,
Right.
oh, yeah, same if it's negative.
And since there's no
Right.
number on x squared, it's just.
We said for the first one, there's only one.
So what are we trying to do?
But those agrees for y. It still has.
Right now, we just said list all the key
On the
characteristics.
second one.
The x and the y
Just
intercept.
remember the 5, 0 is the,
And on the last one, we said.
So the x-intercept is right there. What is that?
Still has two.
well, then,
Mm-hmm.
Don't have.
Yeah. well, then what's, like, is there 2 points for A then?
Well, then how this part right
Whenever
here.
somebody tells you, let's say A is right here, then you're supposed to assume it's on that, but if it's not a parabola, and it's just an
So we didn't
equation,
talk
what
about the
if
b
it
much
just kept going?
Oh,
because the b is not super important. Like if you do everything really algebraically, it is.
It just
Does
literally
anyone
just
remember what the
decides
c
it's negative
is though in the standard form?
So.
So like we can't see it, but that tells me my y-intercept is, what's the x value for y-intercept?
So you're just.
0, comma.
What is x-intercept?
Which should make sense, because what is 0 squared?
Hey, let's all do it together, so x-intercept, you
Right,
know where the
minus
x
10
line
times
is,
0
right?
is,
The
what's 10
horizon.
times 0?
Just think, just, what I used to
So
do
what I
was it
remember
was
for
a
y-intercept, what is
would
the x
stand
value?
up on its own, on a flat surface.
That's why I'm substituting
Think
0
about
in.
the letter
Notice
y,
both of those
it
become
falls
0,
over.
so I'm just
So
left
x
with
though,
5.
X can stand up perfectly fine on a flat surface. So x,
We don't have an
or you could make
example.
y, cause
What
it
do you
has the
mean?
long
So
way.
what is vertex? Y equals what?
But our x-intercept would be 5, comma 0 because it touches the x line at 5, and then
This
8,
one,
comma
comma
0
k is your vertex.
Oh.
for the x-intercept.
0, 0, and 0, so the x-intercept was.
The x would be.
Oh.
You see the line? So we were defining the x-intercept, since it touches at 5, it'd be 5, comma 0, where does that 0 come from?
Okay, that just means that it's not.
Have you found your axis of symmetry for any of
It's only
these?
0 on the line.
Oh, okay, okay. 5, comma 0, and then the y-intercept.
And then for the
You
y,
can just
it's
type
gonna
that.
be 0,
Do we have any idea what the axis of symmetry might be for the first one?
This one,
Yeah. Should we use that
okay, we started with the numbers.
That's a point though. Would that be an axis of symmetry, which is a
So
line?
y-intercept would be.
X-intercept.
So this is something I've started to notice on the graphic organizers I get back today. We forgot how to write the equation for the axis of symmetry.
Oh, yeah.
Remember, the axis of symmetry is a vertical line through the
C is
vertex,
always the
right?
wire, so.
And so
And
it doesn't matter what the k value is, the x value is always
Yeah.
h.
what is B always?
matching the vertex.
B is the
So
second one.
x is always equal to
Oh,
h.
like the second one from.
Yeah, but does it have like a name, like, you know, 25
Right,
is
the
divided?
vertex.
Second
The
one.
next one, the vertex.
So
It is,
we-
you had a lot of the correct information there. Why'd you erase it?
On the last one, it has no.
When did I tell you that any of that was wrong? There was more information you needed to add, but as far as I could tell, none of that information was wrong.
I like the axis of symmetry.
Not quite. Because here's the thing, look right here. That point is 5 comma 3. That's 5 comma 1. That's 5 comma negative 1. So every point has what in common? The x is equal to 5. The equation for the axis of symmetry always needs to be x equals something. Does that make sense? Specifically, if you remember back to the vertex form, x is equal to h every time.
So do we need to put it in a different form to get, what does it give us in vertex form, RO?
You
Oh,
have
you
the
don't even
graph
have to
already.
put it in a form.
Okay.
You have the graph, like, you
So
can base
that's
it
what
off
I'm
of
saying,
that.
is what else do we need besides y-intercept, x-intercept? Remember zeros. The x-intercept, y-intercept, axis of symmetry, and the vertex. I'm confused, is the vertex not?
No, that is the vertex.
It's just also happens to be the axis, or the x-intercept.
Okay, so vertex.
We can say we're different, we have different definitions.
And then the axis of symmetry.
I have a quick
Is
question.
that like if
I
you
know
just
that
choose-
most of us are not done, but do we feel like, based on a graph, we can identify the number of zeros, the x-intercepts, so that we can move on?
Yes, that's
And talk, like, we'll talk through these and make sure we have all the correct answers down. But do we feel like we understand how to do it, or do we need a little bit more practice individually before we go over it? Lexi's good. Jaden, what's your vote? Do you need more individual practice in your small group? Yes?
I like doing it in the small
You good?
group.
Okay. Cameron,
I'm good.
you good? Shannon? Okay, so we're gonna go over these, make sure we have all these details down correctly, make sure you take notes on this. First off, let's go ahead and start with the x-intercepts. So what is the x-intercept right here?
5,0.
5 comma 0, that would also be what else?
The vertex,
And
axis of symmetry.
vertex. Okay, be careful, 5 comma 0, can that be an axis of symmetry?
X equals 5.
X equals 5. That's a huge part of the axis of symmetry, but remember, this is a point. The axis of symmetry is a vertical line that goes
So
through the
what
middle.
do we put, because it starts at 5, but it goes up the whole time.
Well, you say it starts at 5, it starts at 5 comma, well, we see it at 5 comma 0, but remember,
5,1, 5,2, but yeah, but what do you put as the answer? Like, if you were to ask us like, x, that's it.
remember, every point here, what is the x value?
5.
So the axis of symmetry, remember, we even talked about it, is always x equals h, where h is the x value of the vertex. So for this case, x is equal to 5. Every x value is 5.
Yeah, I was saying if somebody was like, what's the axis of symmetry? I feel like I'd need to put like 5 comma 0, and then 5 comma 2, 5 comma, you know, like a
But how many points are there actually for this line?
many. That's what I'm saying is you would do 5 comma, and then you put like an x or something, and then that would be
But
what I would think.
you're missing, go back to the question I'm asking. How many points are there?
Infinite.
Infinitely many. Can you write all those points out?
No, but you
That's
could-
why you need an equation, x is equal to 5,
Yeah.
right? Because what I'm saying is, it doesn't matter what y is, I'm saying that the x value is 5. So every single point where the x value is 5 is a point on that axis of symmetry, okay? So we've got x-intercepts, okay, I got axis of symmetry, vertex, the y-intercept. I can't see that y-intercept, what's it gonna be? Ooh, be careful. No, that's not what I'm thinking we missing. Thank you. So remember, what feature is revealed from standard form? Not the 0,
Oh, the y.
the y-intercept, right? Concavity and y-intercept are given in standard form. That c value, remember, is the y value, the y-intercept. Now, here's an important detail. How many zeros are there? So remember, we talked about this briefly yesterday. You didn't have to write this, but if you were to write this in factored form,
Oh, 2.
there's still 2, right? There's one x-intercept, but how many zeros are there? 2, right? Because 0 is equal to x minus 5 times x minus 5. There are 2 zeros, it's just that they're the same 0, so it's 1 x-intercept. That's a huge difference. Jeremiah, you good with that information? Kylie, you comfortable with that? Okay. And so we come over to the second one and we start putting that into practice again. So what are my x-intercepts?
0, 0, and 0, 6.
So 0, 0, and
0, 6.
0, comma 6. Y-intercept?
0,
0, 0.
Is it 0, 0, or 0, comma 3?
Oh, it's comma 3.
0, comma 3 be up there.
Well, 3.
I put 0 because it's written in standard form, so it's just known to be 0.
That's another thing to notice, right? It is standard form, ax squared plus bx plus c. It's not written there, but we understand that c to be 0 plus 0. And can we see this intersecting the y-axis there?
Yeah.
That's what we're gonna look at.
Yeah, I was thinking of the axis of symmetry again, because
I got
last
you.
time it was the same.
But notice but the axis of symmetry is the same as has a part in common with the
Is
vertex.
it the x equals 3 goes in?
So axis of symmetry would be x equals 3.
Okay, that's what-
What would be my vertex? Hopefully we were able to identify it.
I think it's
3, comma 9.
Yeah, 3, 9.
Yeah, remember positive 2, 4, 6, 8, which looks like a negative there. But yeah, 3, comma 9. Again, notice the axis of symmetry, x equals 3, or h, the x value of the vertex. Yes, ma'am? 3? Look at your vertex in the book. Isn't that an x value of 3?
What?
You talking about the axis of symmetry? Or the vertex?
Which one, where you get 3 from? How you get 3?
Well, I'm looking at the vertex, right?
Yeah,
Here's the vertex.
okay.
What's the x value of that vertex?
But it's on 8. And you look at, in the middle right there at the top.
Oh, yeah, well, he's saying the axis of symmetry, like where, if
Well,
you take the line
she's-
down,
she's
where
talking
on
about
the
the-
x-axis it means.
Remember, this is x. The x value is 3.
Oh, I see what you.
But also be careful, the y value is 9, not 8.
Yeah, no. Oh, I see what you.
So 3, comma 9. Yes, Cameron?
How do you write the axis of symmetry again?
Always x equals, and then h, right? Remember that, because, and this is what we were talking about with Gracie earlier, this is the axis of symmetry of a line, right? It doesn't matter what point you pick on that line, they all have one thing in common. Look at every single point on this line. What do they all have in common?
3.
The x is 3. So literally, x is equal to 3. Is the set of all points such that x is equal to 3? Does that make sense? So the axis of symmetry is always x equals. That is a comment that I made on your graphic organizers. Oh, by the way, you will see on your graphic organizers the letters BS. If you see that, that means be specific,
Okay.
just to clarify.
BS.
Yeah. One of my high school teachers did that to me, and I was so confused until one day we asked her, I just want to be upfront with you, whenever, and I like that because it saves me a lot of time. BS means be specific. Yes, LaShannon.
So, with the, on the first one, with the accent should be 5?
It was x equals 5.
Yeah, that's what it's
Right.
That's how you write it, just x.
X equals, and then h. Yep, the h, the x value of vertex. Okay? Finally, a quick and important detail here is how many x-intercepts are there? Or how many zeros are there? 2. Once again, there are 2 zeros. There are 2 zeros there. And now it's important to look at the last one. Let's start with the x-intercepts. How many x-intercepts are there? Or what are the x-intercepts?
There are 9.
There are none. There are no x-intercepts. Never intersects the x-axis. What about y-intercept?
0, 0.
0, 0, 1.
Right, so be careful. If it was 0, 0, we'd actually be intersecting the x-axis, right?
Oh, I did the same thing I did on the second one.
Y-intercept, what else do we need? Think vertex,
0,
0, 1. Axis of symmetry, x what? X equals 0. And once again, I have the question, zeros, how many are there? Even though we don't have a single x-intercept, a parabola, a quadratic function always has how many zeros? 2.
So all three of those are two?
What, in a quick and dirty way, not dirty, a quick and easy way to see it is, what is the power of a quadratic function? How many zeros are we going to have? If you have a cubic, x cubed, how many zeros are you going to have? 3. If it's x to the 17th, how many zeros are you going to have? 17, right? The power tells you how many zeros or how many roots you're going to have. Yes, ma'am?
Are you gonna ever have 0?
No? Not with, well, if I were to ever give you the equation y equals 7, right? Y equals 7, similar to x equals a number, y equals 7 just means it's now all the points that have a y value of 7, it's a horizontal line. Is that ever crossing the x-axis? No. But if you have y equals 3x minus 4, notice the exponent here is 1. How many x-intercepts or zeros are we going to have? 1. The power on your exponent or on your variable tells you how many
So all of
zeros or
them would
roots
have
you'll
2
have.
zeros?
If it's what kind of function?
No, I'm saying, well, yeah, quadratic, but I'm saying like
Right.
all of these have an exponent of 2.
Correct.
So
So they're
all
going to have
two
how many
zeros.
zeros? 2 zeros. That is not necessarily how many x-intercepts they will have.
Yeah.
But because it is a quadratic, because it is x squared, it is going to have 2 zeros. And so we started to talk about this briefly yesterday, right? Where we looked at Elena and Mark determining the zeros of this parabola. Elena and Mark, they both subtracted 1 to get started. They didn't show that step, but we understand that the way they got here is they subtracted 1. But who is correct? X equals plus or minus the square root of -1, or x equals plus or minus -1? The square root. And here's an easy way to note, remember it and make sure that we are correct. If these were the solutions, that would make the equation what? True. So if I substitute 1 in, is 1 squared plus 1 equal to 0? No. If I put in -1, remember I have to put parentheses around it, -1 squared plus 1, is that equal to 0? No. And so those would not be the zeros because they don't make the equation true.
What is -1 squared? Times -1. Yeah, -1. No. What is it?
What's a negative times a negative?
Oh, positive.
A positive. That's why it would not equal 0, right? Because it'd be 1 plus 1, which is 2, it's not 0.
I don't like that because like in real life, like if you have a negative, that means you have literally none and you've gone beneath that. So it's like if you have like -$2,000 in your account, you can add -2,000, you don't get no positive 4,000, you know? You still just have negative $4,000. So like
But that's not adding, that's multiplying.
2,000 plus 2,000.
Yeah, that's multiplying, not adding.
I know, but in real life, if it's negative, like it's gonna stay negative no matter how many negatives you add to it because.
But you're not adding.
Oh, okay, I get you.
Does that make sense now? Like if you think about the English language and you have a double negative, so
One times.
I don't need no help, technically it would be like I need help. Like it's a double negative. They cancel each other out. It sounds awful, but like,
Wait, I don't.
I mean,
Well, if I say that, that usually means
You're-
like, I don't need help, but like
I don't want help.
Englishly,
Oh, and I guess that's what I
do
should have
need
said.
help.
I don't need no help. It cancels out to say it, yeah.
Yeah,
That's
it's
not
like,
a
it's
good
like
double
in
negative. Hold on.
English, you do need help.
Yeah. I'm trying to think, I'm trying to think of a good double negative. But if you have a double negative, it cancels each other out. That's just bad grammar.
Yeah, I'm
I'm
just
trying to
thinking
think
like
of a double
I'm just
negative.
thinking like
Do
a
not
bank
ever need
account.
Yeah. Hold on.
I do not know.
I do not.
In what?
In Spanish.
However.
I mean, you may be able to, but, double negative example.
I
Um,
don't.
I ain't got
I can't find neither my keys, nor that's not good. That's a terrible
I can't
example.
find neither my face nor mine. Like, what? If I talk like that, slap me in the face. Literally, just tell me to stop.
Yeah, that's not a good, those are not good double
I
negatives.
don't need help,
That's not
like,
what we're
in
for.
English, like-
Anyways, if we have two negatives, they cancel each other out, is kind of the thing. But also, you need to think about it mathematically. What a negative really means is the opposite, right? So if I have a -1, what is the opposite of -1? Positive 1. So one way to think about it is I'm taking the opposite of -1, which would be a positive 1. Okay? But that's where Elena's works. If I take the square root of -1 and I square it and I add 1 to it, what happens between a square root and a square? They cancel. What's -1 plus 1? So there is a need for the square root of a negative. That's what I need you to notice here. You haven't dealt with it before because mathematicians didn't think they were real at first. So does the solution fall within the real number system?
Yeah. Would it not? Because I mean, like the last equation does, because -1 plus 1, like they're both.
But remember,
regular.
Elena started hers, or ended hers with the idea of the square, plus or minus the square root of
Oh,
-1.
well, then, yeah, no.
Have you ever been able to take the square root of a negative before? No. Because in the real number system, you cannot take the square root of a negative. That's the note we want to make here is, in the real number system,
Well, we have negative numbers in general in the number system, then it
but
should.
not the square root of a
I know,
negative.
but that's what I'm saying, is
Yeah.
since we have negative numbers, it should be a real thing, because if you can square root any number that's positive, you should be able to do negative, because it'd be just the opposite.
And that's where the complex number system comes in, right? So in the real number system, you cannot take the square root of a negative.
But it's still correct.
Right, but that's why it's not the real number system.
So we're not gonna get in trouble, like, in the future, if we were to put that, and then they'd be like, nope, that's not a real number, and then,
Well, now you know the complex, we're learning the complex number system, so now you can take the square root of a negative. What I will point out here is, if you think about a graph, notice all of the numbers on the x-axis, are they real or imaginary? Do we have any square roots and negatives on the x-axis? We have reals. The x-axis, do we have any square root of a negative? We have positives, we have negatives, but no square roots and negatives. So the x-axis is all real numbers. The y-axis is also all real numbers. So when we graph, why were we not able to see any x-intercepts? Well, because what kind of numbers do we not have on the real number system? The roots of a negative, right? So we cannot see x-intercepts that are complex numbers because we only have real numbers on the graph. Yes, ma'am?
okay, so the ones that you said, if it didn't have an n, like if there's a repeating number, like that, what is that called?
If it's a repeating decimal, it's rational. We're gonna get to those in a second, though.
So there's rational, what is complex? Complex is,
We're gonna get into it. Just hold on for a second.
I just need to.
It is literally in 6.2. That is what 6.2 is about. So first, before we get there, though, we need to properly define a complex number or an imaginary number. So please hear me very clearly, and I talked about this yesterday. I, yes, it's a letter, but in math, it is a number, okay? Which everyone gets all frustrated by that, but tell me this, what is pi?
3.14.
No. Can't remember all of them because it's irrational. So that it keeps going forever and ever. In fact, that's where I know to, because when I was in high school, we always had a pi day right before spring break, and on March 14th at 1:59 p.m. and 26 seconds, we had pi day.
That's dope.
And
That's
people
at
in my
least a
school
good way
did
to
memorize
learn.
pi out to 50, 100, 150 decimal places. I didn't ever
What's
do
the
that.
point of that? Like, it's like those phones have kind of made
Correct.
half of our subjects obsolete.
Correct.
Like,
That's why I
like
don't-
grammar. I don't get
Okay,
grammar.
I need you to stop talking over me so that we can focus on this math. Alright, but I need y'all to hear me very clearly on this. You don't think of pi as a letter, but it is. Pi, if you ever go into the Greek system at UA or any Greek system, that is a letter. It is a Greek letter. When a number is so special that we're going to use it over and over and over again, we give it a letter that always represents it. Pi is the Greek letter that represents 3.14159. There is a number known as E, Euler's number. This is a number that shows up throughout history, time and time again, 1, 8, 2, 8, and it keeps going. Euler's number. That is an irrational number, but it's so special, we assigned a letter to it, so that in math, if you ever see E, it means that thing. Okay? So we have now the number I. If I squared is equal to -1, then what is the value of I?
It's not as bad as Ethan snoring during the exam.
Okay. I squared is equal to -1. Y'all are making this way too complicated. What am I going to do to solve for I?
What's -1 squared?
It's not -1 squared. Well, it's I squared, I want I, so what do I need to do?
Divide.
Say it again. Thank you. It's I squared. What's the inverse of I squared? Square root. Y'all are making that way too hard.
I thought it was bigger.
Why are they curved like that? You don't have to do it, but
It's like a J.
that's a J.
It's a backwards J.
It's not a backwards J. It's more like it's a cursive thing, but it's also like, if you have that and that, sometimes you can lose sight of that dot up top and it looks like a 1 instead of an I. It's the same reason that when I do a T, I do the curve right here so it doesn't look like a plus. So that's why I do that.
Technically, I'm right. It is a backwards J.
Oh my gosh, Gracie.
It would be.
You're just looking to argue instead of learn.
It's right though.
Nope, I is equal to the square root of -1. Okay? Now, technically, it's plus or minus the square root of -1. We'll get actually into the next, in 2 units, why we only look at the positive. But we define I as the square root of -1. We define I as the square root of -1.
What you got C? What is C from?
Huh?
That's not I. I'm looking at this, it says C equals.
I
That's
Is
not
equal to the square root of -1.
It's a backwards J.
We just talked about that I don't look right like this, because if you lose that dot, what does that now look like? A 1.
She said it's a backwards J too.
I mean, you can say it's a backwards J all you want, it is an I. Okay?
No, it is, yes, but I'm saying.
So I is the square root of -1.
Next question.
Nothing's wrong with
It
that.
is not English. Can you go to the next problem?
I'm not.
I mean, English always matters, but we need to
I know,
focus.
I'm saying, cause you
But Gracie, we have math content to learn. Let's focus on the math content. So remember in number 4, we already looked at x squared plus 1. When Elena solved this equation, she got x equals plus or minus the square root of -1. So how would we write that now knowing about this number I? I don't want to.
When you replace the x with I,
Say it one more time.
when you replace the x with I,
Not the x.
You replace the.
What is I equal to?
The square root of -1, so you replace the square root of -1?
Replace the square root of negative 1 with
I.
I. So you would say x is equal to plus or minus I. Anytime you have the square root of negative 1, what can you substitute in for the square root of negative 1? I, right? And so maybe if you're struggling with that, you might want to write down if I is equal to the square root of negative 1, I can be substituted in. Well, that's your one part. Actually, Jada had her hand up first, so I'm going to let her ask your question, and I'll let you ask yours. I can be substituted in for the square root of negative 1. Jada, what was your question?
Why does it have a P?
Why does it have a what?
P for it. What's it?
Where?
Not a
P,
with the.
on number 4 in the equation.
Oh, p of x. I mean, it's just a function notation. Like, I usually use f of x, but you can have p of x, you could have g of x, you could have h of x.
Oh.
It's just a function notation. So it's probably p for polynomial, the polynomial function,
Oh.
but it's just function notation.
I'm confused about one thing.
When you got the answers, that's 2 i's.
Plus or minus I.
Very so close.
Alright, hold on, Gracie has a question first.
It's x to the second plus 1 equals 0, and then you do minus 1 on both sides, but how did the x to the second disappear, like the second?
It didn't. We already worked it out once on the previous problem, so I just didn't write it.
It cancels out.
Okay, it equals negative 1, the
Plus
square
or
root of
minus.
negative.
Is that beside the square root of negative 1, is that a comma or a 1? In your like statement part.
Comma, right there. If I is equal to the square root of negative 1, comma, I can be substituted in for the square root of negative 1. LaShannon, did you have a question?
Oh, no, I couldn't see.
Okay, sorry. Okay. So looking at number 5, it says, how can you tell from the graph whether or not it has real solutions or imaginary solutions? And when we say the word solutions, another way to think about that word is roots or zeros. Why looking at that graph was it like, okay, we still have 2 zeros, but they're imaginary? What did they not?
So could you just put x equals plus or minus I?
Yes, that's
Okay.
literally what I have up there. Okay. Come on, when we look at that graph, why did we know, or why should we know that those roots had to be complex? There we go. Remember, if they are real, they're also called x-intercepts. This is why we need those terms zeros and roots, because if they're not real, if they're complex, they're not x-intercepts. So when we look at number 5 here, how can you tell from the graph whether or not it has real solutions, and really we should say roots or zeros there, because the roots are not what? So they're not x-intercepts.
So, will it make that graph true, or?
Well, it would still make the equation true, right? So remember I showed you that earlier. If I take the square root of negative 1 and I square it and I add 1 to it, does it equal 0? It still makes the equation true, right? But it's a complex number, an imaginary number. It's not a real number, right? That's why those roots are not x-intercepts. So we can tell from the graph if we have complex roots or not, because how many roots do you always have? 2. But if there's no x-intercepts, those 2 roots have to be imaginary, complex.
So there's still roots regardless,
Mm-hmm.
even if it's not touching that, it's
Correct. It's not touching the x-axis, right? And that's what we know, it's x squared, so how many roots are there? 2. But if we don't have any x-intercepts, right, they can't be real, they have to be imaginary.
So it'll make the problem true.
It'll still make the equation true, right?
Yeah.
But they're not real, they're complex.
I just wanna know, what is the imaginary ones? Like, I get, like, we put that it's imaginary, but we also said it was complex, and it's.
There's not really a huge difference, the textbook makes a difference, we're gonna look at that at 6.2.
Okay.
So do you think you can determine the imaginary solutions by examining the graph?
No, they're imaginary.
They're imaginary, and also the graph only has what numbers? Real numbers. The graph only has real numbers.
If someone asked you to solve it, wouldn't you just assume that the complex or whatever numbers are in the graph, they're just not the same? Like, if you have a point in between 2 and 1, like slightly closer to 1 or something, like you can assume it's probably like 1.1567.
But if you, even if you have 1.7523 yada yada yada, comma, negative 2.78, is there an imaginary number there? No, those are both real numbers. The Cartesian coordinate system that you're used to only has real numbers. Now there is something known as a complex coordinate system that we're not going to get into, where the real number system is on the x-axis and the imaginary number system is on the y-axis. We're not going to get into that. If you were to graph this function on here, you would see roots on the x-axis. No, don't worry about it. We're not getting into it. What's up?
What's that word you just said?
Well, I haven't finished writing. Graph only has real numbers, so. Huh? Oh, Cartesian coordinate system? So the Cartesian coordinate system is called that. And that's just the coordinate system that you're used to, the x and y coordinates. It's called a Cartesian coordinate system because a gentleman named Rene Descartes, I don't know if I'm even coming close to spelling that right, probably not. But he was a philosopher and a mathematician sometime in the history, but his name was Rene Descartes. He came up with the Cartesian coordinate system, or developed it
I would
heavily.
love to have something named
Okay, so the graph only has real numbers, so you can't see complex roots.
I want like.
Okay, so make sure you have that note. The graph only has real numbers, so you can't see complex roots. But that is a good question. If you ever have a question of like, where in the world did that word come from? I have some weird, useless information, but it's still fun to know.
That's me, I love random just vocab words and nobody, like, they're like, what does that mean?
Yeah, Cartesian. Yeah, I don't know why high school teachers don't use that term very often, but we don't.
That's the first time I've ever heard that word.
Yeah, Cartesian coordinate system. It's good, you know. It's just the name of it.
It's like a type of food.
I have to look up.
Some Cartesian.
Alright, does everyone have 6 written down?
Yes.
Everybody got it written down? Okay. So here's the thing, right? So this is what Gracie was getting frustrated about earlier. You need to make some notes on this. This is actually on the graphic organizer as well. We're going to break down some of these number systems. The set of complex numbers, right, is a set of all numbers written in the form a plus bi. Well, what really important number have we just talked about that is a part of that complex number? I, right? That I is the square root of -1. Notice it breaks down some of this stuff. The homework that y'all have due next week, there's a right component to it. It comes straight from here. If you know this and you read through this, you're going to be golden. So the term a is called the real part of the complex number. Any guess why it's called the real part?
Is this a real number?
It's a real number, meaning it does not have what part to it? I. The whole thing together is complex. But this is known as the real part of that complex number because it doesn't have the I. I is literally the imaginary number, right? So this is known as the real part because it doesn't have the I. Bi is called the imaginary part of the complex number because it has the I there. So the set of imaginary numbers is the set of all numbers written in the form a plus bi, where a and b are real numbers and b is not equal to 0. And the set of imaginary numbers is represented by the notation I. That's right. A pure imaginary number is a number of the form a plus bi, where a is equal to 0 and b is not equal to 0. So I will say this.
A is equal to 0 and b is not.
A pure imaginary number, right? So, because like if I have the number 5i, you could have an understood 0 there for the real component.
Okay.
And so that would be known as a pure imaginary because you don't need to write that 0. Does that help clarify that? That's the big reason why we have this